Hi friends, do you know that good data doesn't happen by accident? It starts with a plan. Designing a statistical experiment means setting up your study so that the results are accurate, unbiased and meaningful. So turning smart designs from raw observations into reliable conclusions is the objective of designed experiment in statistics. In this video, I will explain how experimental designs can be constructed to accommodate two-way variation using an RBD. I recommend please watch my previous video on designing statistical experiment 1. It was completely done on a one-way analysis of design, like completely randomized design and other designs associated with that. Okay, so let us have a small recap. A statistical model is a mathematical framework that represents the process by which data are generated using controlled experiment and probability theory. So you will get finally a model y is equal to f of x plus epsilon. Okay, so as I had mentioned in various videos, I have given a very detailed expression and explanations on y and x and epsilon. So statistical models are important as they describe some natural phenomena and they help predict the future status of the model for a given confidence level, and also they facilitate uncovering hidden patterns in the data. And most of the time people and the practitioners want that how to uncover informations from the given data. So why a designed experiment? Experiments can be designed in many ways, and the experiment done statistically will be definitely different from the experiment done in a physics lab or a chemistry lab or any other lab. So the different ways are there to look after the design concept. However, a strategically planned and executed experiment may provide a great deal of information about the effect on a response variable due to one or more factors. So that's why I had shown you the model y is equal to f of x plus epsilon. A well-designed experiment is that which is as simple as possible for obtaining the required information in a cost-effective and reproducible manner. This is a very important challenge for engineers. When they design experiment, most of the time they have to take care of the cost-effectiveness of the whole process, because most of the time design of experiment involves cost, and therefore it is considered to be one of the most expensive tool of statistics. So what are the components required for design? So we need at least inputs. There can be more than one inputs, or you can say treatments or factors, and your experimental unit on which you are going to experiment it. So and the response, the finally the one which we are going to see. So that y is actually the important model variable, you can say, or model y response data. So finally construct a y in terms of the given inputs f of x. Okay, so what are the principles? The main three principles are involved in any design, that is control, randomization and replications. Okay, if those three are present in the process, you can say that you are doing a very good controlled experiment. Okay, so control or local control also is the term used generally for that. When such a designed experiment is performed, the output of the experiment will be completely random. And if you see the randomization replication, they are used to reduce the errors, variation, plus to give overall significance to all the responses, etc. And the experiment can be designed by various design depending on the objectives and given inputs. So I would request the statistics students to see some good books on statistics where you can see various designs used in practical context. So what is a randomized block design? It's an arrangement where experimental units are grouped into blocks based on a known source of variability, and treatments are randomly assigned within each block. So you have two ways of variation which is impacting the output. So one is due to treatment, another is due to blocks. Okay, so and the model will be yij is equal to mu plus tau I plus beta j plus epsilon ij. So with A treatments and B blocks. So there are A treatments and B blocks here. and mu is the overall mean effect, and tau I is the effect due to ith treatment, beta j and j the jth block effect. Epsilon ij is usually the termed as the random error component, which follows generally n0 sigma square. Okay, so design basics is clear, so we can always use two-factor analysis of variance. Okay, let us look at a simple example, and that example will definitely throw more insights to the design aspects and the data collection and plus analysis. So here is a psychologist wishes to study about problem solving ability of persons. So what he does is he considers three types of age groups. One age group is 17 to 25 and called as a young age group, and 26 to 35 being adult age, and 36 to 50 as old age. So they are treated as blocks. So he considers three types of problem solving also. So he takes word puzzles as one of the problem solving method, numerical puzzles such as Sudoku, and these kind of games are very often played by people these days, and picture puzzles also. Okay, so three different types of puzzles, and we all know that different puzzles definitely will have a different age, or the efficiency of solving the puzzles depends on the age group. So what he does is he considers 15% of each age group for the experiment. So that becomes total 45 respondents now. So he distributes each type of puzzles to 5% at random using a simple random sampling technique in each age group. So that's the reason the randoms coming in the randomized block design. So the completely randomized, and blocks are also associated, I mean completely randomized. So you can see how the treatments or the respondents were given the various puzzle types. Okay, so this is the right side. You can see the diagram showing the allocation part. So here is the allocation. So the allocation is done. We'll show you in the next slide. So you can get a 45% with an RBD with 45% as experimental units. So we know that the three different components of design. So experimental units, inputs, and the outputs. Okay, so the treatments and the blocks are also given. So here is the complete allocation. So this is only an allocation. Please don't analyze this table. This is not to be analyzed. So what we get from this, as per the allocation, we have to assign the puzzles for each group, each age group. Okay, so that response, maybe then you may consider it in some score, maybe consider it in some time unit or something, then that score is to be analyzed. So the complete allocation age group wise, puzzle type is also given for each group. You can see each column, 26 to 7, 26 to 35 also word numeric puzzle. You see the allocation of the persons completely random. So the perfect setting for randomized block design. So the psychiatrist will now look at the respondents, and they give the puzzles according to the age group. So after receiving all the solved puzzles back, they were evaluated on a 10-point based scores. So here he did that. So the scoring is done on a 10-point scale. The set of scores is the required data. So here is the complete data. So this is actually the data, and this is what you have to analyze. So you can see according to the same person ID, the table, the change is only that the scores are now shown here according to the person's ID. Please note here is 7, the first column 7, 5, 9, 6. It's not, it's the same, the score obtained by those persons ID according to the ID which is shown in the previous line. Okay, so that is but yes, we need to organize the whole data for analysis purpose, because the previous one again you cannot directly take it into any software. Okay, so you cannot have any, I mean, no software do any analysis of that. So we need to have a kind of organization. So this is what is shown in this particular table. So this is with replication, because I have considered all the observations in the particular. So you can see age group 17 to 25, 25 6 to 35, 36 to 50. Puzzle type for normal puzzle. Can you know what who's which person has been given the word puzzle in which age group, and according to the person's ID, we got the score. So what is shown here is the scope. So this is completely a two table with replication. You can very well analyze this in any software. In Excel also allows the analysis of this. But I feel that this can be much more organized in a better way. So what I have done is I have simply considered the mean correspond to the first cell, say 7, 5, 9, 6, 10. That's coming out to be 7.4. So this makes more sensible because, and this is more easy for taking into any software for calculation. Even manually also you can do. Even with the replication also you can do manual calculation. Many often classroom teaching people do the analysis part. Okay, so here is another way. So consider the mean as the variable here, and that is computed for each cell. And this another way. Look at the median instead of mean. So that could be sometimes more easier. So you can easily get the median once you know the arrangement of numbers. You can take the middle one. So another one. One can also try with the mode. Also, there is no issue. So this is now perfectly set for the analysis. So we can use analysis with the replication or without replication. So analysis is not shown here. You can directly get into the take it into the software and do it. So I request the students and faculties to see how what kind of conclusions it is coming out to be. It will give you very nice, very beautiful conclusions, and again, depends on the context. Not necessary that you can always generalize this result. Okay, so please do an analysis of that. So this is much again in another way. So most of the software demands a kind of organized format in this way. So this is the again without replication, the same previous data which is organized in this. So age group you can see in the first column, and each age group you can see word puzzle is given. So 70 to 25 you can see word, 7 to 25 numerate, 70 to 25 puzzle like that, and the score is also. So here is another way of looking at. So mini tabs or SPSS software sometimes demand this kind of codification. So age group, one means 70 to 25, two means 26 to 35, three means 36 to 50 like that. And puzzle group is again shown in 1, 2, 3 like. So it's another way. The left side and right side is almost same. So only it is coding is done for more clarity and this one. Because most of the time the software demands data structured in this form. So it's very simple. In one click, you can get the analysis if you get this particular data into Excel or Minitab or SPSS. Okay, so what you need to do once you have the analysis in hand, so please take these points into focus. So give importance to interpretations based on the test criteria. So have a good understanding about the design. Only then you can interpret. So what is the block effect? What is the block variations and treatment variations? How they are significant or not? Or how much it is significant? How much they are impacting the output, etc., etc. And also see that model is linear, quadratic, response, surface, etc., etc. You can always have a model, linear. The model which I had shown earlier is actually linear. You can also try quadratic, response, surface, design-based models as well. And third point is very, very important. Always look at the goodness of it, especially the value of R square, adjusted R square, lack of fitness, etc., etc. That all will be coming as output. Look at the table, output table closely, and you will get the value of all this. Simplify the model if necessary by removing some non-significant factors from the model. And this probably may not be required at this point, because if you are constructing a regression model, naturally you may need a kind of omission and deletion and acceptance of some variables, etc., in the model. So, and also identify critical factors that significantly affect the responses, because it's very, very important, because many of our you need a testing of regression coefficients once you have a regression model. So you need to see whether the regression coefficient is really significant or not. So that will decide whether the factor is going to be critical or not. And develop a recommendation plan for the process improvements. Okay, thank you guys. Stay tuned for my next videos on the channel, elucidation and interpretation.